Okay, chi-square test of independence, section 22, page 2. Now all that remains is to look at an example. So below we have below we have actual counts for 3 hospitals and whether the patients are in serious or unserious condition. So here it is. We looked at 4,700 patients. 800 are at hospital A, 200 serious, 600 unserious, etc., etc., etc. So there is our actual table. So the first thing we do is we go to compute the expected counts. So, for instance, what would we expect to find for hospital, given these red totals, given that those are the totals we have to work with, what would we expect to find for serious patients in hospital A if these things really had nothing to do with one another? Well, the bottom line again is it's the row total times the column total divided by the total total. So the 1300 times the 800 divided by the 4700. And that gives us 221.2766. Again, not necessarily a whole number. Obviously, it's got to be a whole number of patients. But, you know, it's the same principles as if you flipped a coin 7 times, then under ideal conditions you'd expect 3.5 heads. Of course, it's impossible, but you keep the accuracy to run through the procedures. You want to have that dead center reference point, whether or not it's an actual realistic count. So keep as much accuracy as you can. This is probably a little overkill. Remember, the one saving grace of hypothesis tests is that close enough is good enough. In the end, it's just a question of whether it's suspiciously small or not. But for the p-value purposes, and particularly for online examines, to get everybody on the same page, let's keep as much accuracy as we can here. So I used 4 decimal places on the grounds that it's probably too much, which is a good place to be. So under ideal conditions, if which hospital you went to and whether you were in serious or unserious condition had nothing to do with one another, were independent, then we would expect, given these red totals, that you would have 221-ish patients at hospital A in serious condition, and so on and so on and so on. The 400 is the actual serious B count. What would we expect? 1,500 times 1,300 divided by 4,700. And that's 414 and change. Hospital C serious, what would we expect given the red totals if they had nothing to do with one another? 2,400 times 1,300 divided by 4,700, which is 663 and change, right? And so forth and so on. So hospital A unserious, given the red totals, what would we expect? 800 times 3,400 divided by 4,700, and that's the 578 and a bit. Hospital B unserious, what would we expect if they had nothing to do with one another, given the red totals? 1,500 times 3,400 divided by 4,700, which is 1085.106-ish. And finally, Hospital C, 2,400, 3,400 divided by 4,700, well, 2,400 times 3,400 divided by 4,700, that gives us the 1736. So there is our point of comparison. Here is the actual, well, here is the actual, the black numbers. Here is the actual counts that we get when we look at this number of patients. And here is what we would expect to find in each cell if the two concepts were unrelated. Again, ideally, like 3.5 out of 7 heads. So from that, we can figure out the chi-square contribution here. So for instance, here, cell for cell for cell for cell. Here is our observed count, 200. Here is our expected count, 221.2766, rounded a bit. So then the chi-square contribution is going to be 200 minus 221.2766 squared divided by 221.2766. Say again, it's this minus this, square it, and divide what you get by this. And that gives us 2.04-ish there. Likewise, and so on and so on and so on. So the chi-square contribution for B series, 400 minus 414, 89.36, square it, divided by 414, 89.36. And that gives us the 0.534643. Hospital B series, 700 divided by the 663.8 thing, square it, divided by the 663.8 thing. And that gives us the 1.97-ish that we get here. Again, keeping a little more accuracy than I think will probably be necessary, just to get us all on the same page. Likewise, 600 divided by the 578 thing, square it, divide by the, 600 minus the 578 thing, square it, divide by the 578 thing, and that gives us the 0.7822 something. 1100 minus 1085 and a bit, square it, divided by 1085 and a bit, gives us the 0.2004, etc. And finally, 1700 minus 1736 and a bit, square it, divided by 1736 and a bit, it gives us the 753546. Finally, we add up those 6 cells. Right there, sum of. We add up those 6 cells to get something along the lines, depending on our rounding, of 6.291478, which again is probably far more than we need. Now again, the degrees of freedom formula is row categories minus 1 times column categories minus 1. So we have 2 categories. For row categories we have 2. For column categories we have 3. It doesn't greatly matter which is which, of course, here. So this minus 1, which is 1, 2 minus 1 times 3 minus 1. Because again, the idea is that if you knew these, if you knew the purple, you could figure out the black, given the red. You could figure out that remaining row and column. So that's why the minus 1 comes into play here. But it's rows minus 1 times columns minus 1. So 2 minus 1 times 3 minus 1, which is 1 times 2, which is 2. So our degrees of freedom formula is 2. So if we're using the, well, what I'm doing here is the 5% level and the 1% level. So what do we get? Well, if we're using the ballpark technique, then we're looking for the degrees of freedom to row, and we're tracking down 6.29 something. Degrees of freedom to row, we're tracking down, what did I say, 6 point something? So it would be on the degrees of freedom to row, it would be between these 2 entries. And therefore, the corresponding p-value, here to the right, is between 0.25 and 5. 0.25 and 0.5, between 2.5% and 5%. So there's our answer. If which hospital you go to and whether you're in serious condition or not have nothing to do with one another, then when we pick 4,700 people of these red varieties, we would get counts as out of alignment with the ideal as we did between 2.5% and 5% of the time. So I'm doing 2 first here, but if we're ballparking it, then yes, as we saw, we're between 7.3 on the 2 row, degrees of freedom 2 row, between 7.3, 7.8, and 5.991 puts us between 0.25 and 0.5, area to the right, p-value. So our p-value is between 2.5% and 5%. Therefore, it is less than 5%, And if it's more than 2.5%, it's more than 1%, which of course would be this way. It's probably on the table. So here's the 1%. Smaller, bigger, p-values anyway, smaller, bigger. So yeah, if we're here, then we are less than 5%, and we're not less than 1%. But, common sense. If you're more than 2.5%, you're more than 1%. So at the 1% level, if you've got to be among the 1% most out of alignment with the ideal in your actual table to be considered suspicious, you're not there yet, and it's not suspicious, and independence is still plausible. We will not reject H0, the independence, and we will find no evidence of HA, that there is a relationship, some kind of dependence, some degree of dependence. On the other hand, if you've got to be among the 5% most out of alignment with the ideal in order for independence to become suspicious, then yeah, it is on the unlikely side of that cutoff point, and therefore it is too unlikely to have occurred if the two things had nothing to do with one another. So we will, as always, if the p-value is less than the level you're comparing it to, then you will reject H0, in this case independence, and you will find evidence of HA. It is no longer plausible that which hospital you go to and whether you're in serious condition or not are unrelated. We have evidence that they are related in some way to some degree. And from that you can dig back into the tables to see what's going on. Hospital A serious is a little less than you would have expected, and so forth and so on. So you can form your own conclusions from there. But we do find evidence of some relationship. Alternately, you can compute the p-value. Now this link, I believe, is dead. The ones that I have on my website are dead links, but I have put up a couple of live ones on the Blackboard. I can't get to my office to change the actual website, but it's on Blackboard. So backing up a bit, if our chi-squared is 6.29178, and with luck I can copy that, and degrees of freedom 2, then pick either one of these calculators. Let's do them both. Remember, we want the area on the greater than side, as the little pictorial thing shows. Same as section 20. So degrees of freedom, what we say 2, and chi-square value, I'm just going to paste it in there, 6.29 something. Hit calculate. Can we blow that up a bit? Again, less than perfect, but 4%, 0.4, is enough to answer our questions. It is not less than 0.1, it is less than 0.5. Same conclusions. Alternately, I think this other calculator I have here, I don't remember whether I had that up before the last video, but this one I think gives you a little bit more accuracy. I don't think I did. Here they want the chi-square value first, and the degrees of freedom after. So 6.291478, degrees of freedom 2, hit calculate. Let's say for the sake of argument you want the picture. Remember, it is the area to the right. You probably don't want the picture, but as always, for our purposes in this course, the chi-square is the area, the p-value is the area to the right. So it's 0.4304. At least that's what this calculator is giving me. The other one's calling it 0.4. What do I have from the dead calculators previously? Well, something in between. A little less accuracy, a little more accuracy. But whether we call it 0.4 or 0.430 or 0.4304, in any case it's 0.4 something. So it is less than 5%. It is not less than 1%. It is less than 5%, so if that's your standard, you're on the unlikely side of things. We reject H0 and find evidence of HA. The A obviously is not printing. For the population from which this sample is drawn, all possible patients who could go to hospital A, B, or C, all possible patients who could or could not be, who could theoretically be or not be in serious or unserious condition, it is not plausible that hospital choice and seriousness of condition are unrelated. We have evidence that they are related in some way. We have evidence that, well, whoever's doing the choosing, whether it's the patient or the doctor sending them, we have evidence that which hospital you go to and whether you're in serious condition or not, in general, is related, because of this sample are suspiciously related. On the other hand, if 1% is your standard, then it's just not that suspicious. It's not that suspicious. Assuming independence, does it occur less than 5% of the time through random chance? Yes, that's suspicious. Assuming independence, does it occur less than 1% of the time through random chance? No, that's not suspicious. This is not less than 0, 1. So we do not reject H0 and do not find evidence of HA, where the A again is not printing for some reason. It is still plausible that we do not reject H0, which is the independence. It's still plausible that hospital choice and seriousness of condition have nothing to do with one another. We find no evidence of HA not printing. We do not have evidence that hospital choice and seriousness of condition are related in some way, in any way. Okay? So whether you do it by ballparking it or whether you do it by looking up an online calculator, well, what can I tell you? At this point, everything is online anyway. Either way, we see what we need to see, and so forth and so on. You know, depending on the calculator, of course, there are limitations depending on the chart you're using to ballpark it. One thing that seems to be confusing people who aren't paying attention, when I ask you to ballpark it in these sections on the quizzes and probably on the exam as well, make sure that we're talking about the same chart here. You know, it's between, I think we said, these two entries. Now, obviously, that depends on the chart you're referencing, but I'm talking about, for the purposes of this course, I'm talking about this chart. 0005, 005, 01, 02, etc., etc., etc. So for this particular chart, it's between those two entries. Some charts will have more columns than others, but that's what we're talking about here. Okay? Likewise, the t-value, if we phrase things that way, is between, I think it was these two, right? Again, that depends on what chart you're looking at. We're using this chart. So there is an example of a chi-square independence test. We can do more in the discussion board if people change their habits and miraculously start asking a lot of questions. But that should wrap it up for new material, giving you the usual 2 weeks or so to do the online quizzes. And from here, it's just thinking about the final on my end and answering questions from you guys. Okay,